All right, 5.1. Angles of triangles. All right, so first we're going to review some concepts. What would make x have to be to make the lines parallel? All right, well, if we look at this angle here, whoopsie. If we look at this angle here and this angle here, they're both obtuse. They're both exterior and they're alternate sides of the transversal. So they are alternate exterior angles, which means they must be congruent for M and N to be parallel. So therefore, we just say 2x equals 138. Divide by 2, x equals 69 degrees. All right. Over here, we have an acute angle and an obtuse angle. Remember, when we have one of each, they can't be equal because one's obtuse and one's acute. So our only other option is, in this situation, is they must add together. So here's my acute plus my obtuse. They must add together to 180 because they're supplementary if the lines are parallel. So first thing I'm going to, excuse me, first thing I'm going to do is I'm going to add these two together, simplify the left side. 6x plus 144 equals 180. Now I'm going to subtract 144. So that's going to give me 180 minus 140 is 40, minus another 4, that will give me 36. Now I divide by 6, and I get 6. All right, and I can check that real quickly. If I plug this in, 6 times 6 is 36, plus 4 is 40, 140 plus 40 equals 180. Good to go. All right, this is just some terminology you need to know. All right, so first off, we can classify triangles by their sides or their angles. Sides, if there's no congruent sides, we call them scalene. If there's two sides that match, at least two sides, is isosceles, and equilaterals, all three sides are congruent. The angles, if all the angles are acute, it's an acute triangle. If one of them's right, it's a right triangle. If one of them's obtuse, it's an obtuse triangle. And if all the acute angles are also congruent, then it's called equiangular, just like equilateral. This means equal sides, lateral means sides, and this means equal angles. All right, now in your notes it's hard to tell, but you can see here that we have markings showing that these two sides are equal. Nothing down here, all right? So that means that this is an isosceles triangle, all right? And if you took a protractor, but you can see these are all acute angles, so we don't have any, if we measure them, they would not all be equal. If they were all equal, all the sides would be equal. So this is just an acute triangle. Or we call it an acute isosceles or an isosceles acute. All right, classify this triangle by its sides. Then determine whether it's a right triangle. So we're looking to see, we're assuming they're wondering if this is a right angle right here. Looks like it might be, but we're not sure. To know that, we need to know the slopes of the angles here, okay? So we need to find the slopes, but also to know whether the sides are equal or not. Obviously, this side is shorter, but is it isosceles? Or is this side and this side equal? We won't know that unless we do the distance formula. So I'm only going to do the distance formula for OQ and PQ because obviously the shorter side is not equal, so it's not acute. So OQ, so we're going to do the square root of 6 minus 0, and really you don't really need to waste time doing that part if you don't want to, plus 3 minus 0 squared. So that's going to be 36 plus 9, which is the square root of 45. We can leave it like that. We don't care what the decimal is. Now I'm going to do PQ. So x minus x. So be careful here. If I do 6 minus negative 1, it's going to be 6 plus 1. plus 3 minus 2 squared. You can probably see where this is going. 6 plus 1 is 7, so that's 49, plus 3 minus 2 is 1. So this is the square root of 50. So none of the sides are equal, which makes this scalene. But now we need to determine the slope. Now, in this case, we don't have to do the slope formula. We can just count. So we can count from O to Q. So we go up 1, 2, 3, and right 1, 2, 3, 4, 5, 6. So the slope of OQ is up 3, right 6, or 1/2. The slope of PQ is going from here. I'm going up 1 and right 1. I'm sorry, my bad. I don't need PQ. I need OP. Sorry. We're looking at this line here and this line here to see if they're right. It's a right angle. So OP, we're going up 1, up 2, and left 1. So we have 1/2 and -2/1, which are opposite and reciprocals. So this is also a right triangle. So it's a right scalene triangle. All right, draw an obtuse triangle and an acute scalene triangle. Then find the measures of each angle using a protractor. Okay, we're not gonna, you can just copy this down. We're not gonna have you measure. So I'm gonna make a triangle here. This is clearly an obtuse angle here. We're gonna say these are equal side lengths, all right? And then an acute scalene. So just a little bit longer. And we're going to say this and this and this are all different measurements, and all the angles are acute. All right? If you measured all the angles, okay, you would notice a couple things. You would notice that these angles would be equal to each other. Okay? You would notice that all these angles are different measurements. All right? So if you have two sides equal, you have two angles equal. If you have three that are not equal, same with the angles. You would also find this next concept, that all the angles you measured added up to 180 degrees. That's every triangle. Okay, now, what we know here is that this angle 1 plus 3x plus 40 equals 40 degrees. Sorry, 180 degrees. Also, I just realized something went wrong. This skipped a slide. I don't know how that happened. Now, here's a new theorem based on the previous one. The measure of an exterior angle right here, all right, 1, is equal to these two angles here, A and B. Okay? So, this right here is equal to those two added together. So, 40 plus 3x is equal to 5x minus 10. All right? So, what we're going to do is simplify. So I'm going to subtract 3x from both sides. I'm going to add 10 to both sides. And what that's going to give me here is 50 equals 2x. So x equals 25. Right? Now, I have a few different ways of going about this. Okay? So I'm going to go through all of them. You do what's best for you. If we know x is 25, we can plug in 25 right here and find out the exterior angle. And the exterior angle and angle 1 add up to 180 because they are a linear pair. So if I did 5 times 25, that would be 125, 5 quarters of $1.25, minus 10, right, would be 125 minus 10 is 115. So this angle here is 115 degrees. So if I just did 180 minus 115, I would find out that angle 1 is 55 degrees. That's one way to go about it. Another thing to say is, well, actually that's the best way to go about it. But another option would be, if you wanted to, I mean, it's your personal choice, you could also plug the 25 in here, all right, and do 3 times 25. If you did that, you would find out this angle here was 75 degrees. And then what you could do is do 75 plus 40, guess what it is, and subtract that from 180 to get 55. So it's just 2 different ways to approach the same answer because of the relationships of the angles. You choose what's best for you. Okay? You can plug the 25 in either place and solve for the missing angle. All right, so in this one, we know all 3 angles add up to 180. I'm going to show you a shortcut on this one also. It depends on what's best for you. So if I take 2x plus x minus 6 plus 90, because this is 90 right here, I'm going to get 180. So I'm going to join my like terms. That's 3x. 90 minus 6 is 84. And I'm going to subtract 84. So 180 minus 80 is 100. Minus 4 is 96. And then if I divide by 3, I'm going to get 21. All right? Then I plug 21 in right here. 2 times 21 is 42. And 21 minus 6 is 15. And that's not right, because 3 goes into 6 2 times. This is 22. My mistake. I don't know what I was thinking. And this should be 32. So I don't know what is going on in my brain. It's not working very well. Sorry about that. 3 goes into 9 3 times. 3 goes into 6 2 times. It should be 32. These things happen. So 2 times 32 is 64. 32 minus 6 is 26. Now, guess what? 64 and 26 add up to 90, right? That makes sense, because if 90 degrees is here and the whole thing's worth 180, that means the other 2 angles add up to 90. So here's the shortcut. You can just take 2x plus x minus 6 and set it equal to 90. So that would be 3x minus 6 equals 90. 3x equals 96. Look familiar? X equals 32. So it just saves a step. It's a little quicker. Doesn't really matter. You can do it either way you want. But that leads to this corollary. If you know this angle is 90, then these 2 add up to 90. So some people like to do the whole thing and add up to 180, but that is a nice little shortcut. All right. It's hard to see in your packet, but you can see it here. If in the painting, the red triangle is a right triangle. Okay, so that's going to be right here. The measure of one acute angle is twice the measure of the other. Find the measure of each acute triangle. Okay? Well, that means one of the angles is x. The other one is twice that angle, and they're going to add up to 90. So that's 3x equals 90, x equals 30. So that means one angle is 30, and the other one is 60, which you probably could have done in your head ahead of time, but that's the algebra behind it. And that's it.